Hello, everybody. I'm Chad, and I'm going to give you a talk on ECMA script decorators. So before we begin, this is my Be My Friend slide. I've seen people bake these slides before, but I'm just giving social media stuff and some hobbies. Maybe we have a hobby in common. You never know. We could be friends. So yeah, take a look at that and consider it. So kind of get going here. So people like to decorate their houses. This is some grand example of some decoration here. I actually tried to talk my wife into doing this color scheme for our kitchen. She said no. People also decorate their stuff. So this is my computer, which is actually this right here. So, you know, people like to add decorations to everything. People like to decorate themselves, like everything from your clothes to your haircut to tattoos. Decorating is pretty much, you know, part of being human. So you may ask yourself, can I decorate my JavaScript code? Yes, you can. So this is some example of some ECMA decorators that is part of the Ember framework. So you can see we have some of these like @ symbols here decorating three things. We have service, computed, and action. These are just sort of examples to show you what it should look like. So the service thing actually kind of adds like a dependency injection thing to inject that particular property in with a service. Computed does the memoization, and action kind of like signals to the Ember framework that this particular method is be able to use by templates as a template action. So you may ask yourself, why? Why do we need decorators in our life? Well, so decorators are a way that libraries and frameworks can add behavior to your classes. Before, there was like people have tried different ways to do this in JavaScript, and they all have some pretty big negative cons, and I'm going to go through some of those. Like one of them is mixins. Back in the early days of React, in fact, they actually used mixins to like inject things into your components and whatnot. And Facebook came back and said, oh, this is horrible, stop doing this. Part of the reason is it's actually kind of difficult to do with ES6 classes syntax. You know, it doesn't really give you an opportunity to do that. So you kind of had to use the thing where you had like a plain old JavaScript object, you pass it to a function, then you pass in your mixins and whatnot. But this kind of made some for really complicated code. Like there's like a lot of ambiguity that can happen between mixins. Sometimes you had to chain a whole bunch of mixins together to get the behavior that you wanted. And it just actually became a huge mess in a lot of code bases. So that's why kind of the React, for example, and a lot of other frameworks made the call and says, let's not do mixins anymore. Next is class reopening, which kind of came from Ruby, and very few frameworks picked it up, and it was very short-lived because it ended up being so bad. And the way that works is it takes classes that you've defined, implicitly changes them somewhere in the JavaScript framework, and it's really kind of not clear where, because it could be anywhere. And then you get this like behavior that's been injected into your classes. And that was kind of a mess because it was so implicit that it was really hard to tell where that behavior was coming from. And class inheritance is basically a lot of what people have been doing. It's probably the most stable option, but it comes with some negatives too, because it basically, you just inherit from that particular framework's class and you get all the behavior for that. But that's kind of limited because you can't really compose things together because, you know, JavaScript has sort of like a single inheritance sort of model. And so it was just really not that great. But decorators are great. Decorators, actually, the behavior change is really close to the properties that you're actually modifying, basically adding behavior to. So that thing that like modifies how that property works can be right next to that property. And that thing that changes that how your method works is right next to the method. In fact, it's so great that frameworks have already been picking up on decorators, even though it was really early in the proposal process. So TypeScript actually already has some decorators. MobX actually takes the use of decorators in its framework. Angular does as well. Ember is picking these up actually pretty recently. And then even like libraries, functional libraries like Lodash, which just give a whole bunch of utility functions, they have adopted this too. So you can actually download a Lodash package that has a whole bunch of decorators that you can add to your classes, which is pretty nice. But I want to point out to this thing. This is a screenshot of the TypeScript documentation. It says, note, decorators are experimental feature and they may change in future releases. So surprise Pikachu, they have changed quite a bit. So like the TypeScript is no longer actually up to date with the current state of this proposal. So the rest of this talk, I'm going to try to teach you what the current state of this proposal is, because it is kind of close to getting into stage 3, which means it's almost ready to implement. So by that time, all this stuff shakes out, you'll probably have a better idea how to write decorators. So like I said, the current state is stage 2. It's actually, there's a meeting coming up on the 29th where they're going to vote and see if this is actually ready to go to stage 3, which means that that the JavaScript implementers are going to start implementing this in their core engines in order to bring it up to stage 4, which stage 4 means it's done. So so it's really close to being finalized now, hopefully. In fact, as I was writing slides for this last week, they actually changed a whole bunch of stuff. So I actually had to go back and change a lot of my slides to basically show what the current state of the proposal is. If you want to play with this right now, this one was a little bit out of date. You have to have Babel 7.1. So if you have an older version of Babel or not using Babel at all, you might need to update that. And I listed the plugin here. So the stuff in this actually is a little bit out of date because there is a PR request actually in the progress to show this version of the proposal. So the proposal that's going to get voted in to go to stage 3 in a few weeks is just sitting in PR, getting ready to get merged in. But hopefully by the end of the talk, when that gets merged in, you guys will be ready to write your own decorators, maybe. So the first concept we got to talk about when we're talking about decorators, the new decorators thing, is property descriptors. Property descriptors is actually ES5 feature. Has anybody ever messed with property descriptors before? You probably haven't, because it's one of those things that's kind of really deep nitty gritty into JavaScript. Like some frameworks use these sometimes to do some of their magic, but you're probably in a lot of like user-line code, you're probably not going to see a lot of this. So the way property descriptors kind of work is you have this get on property descriptor, which kind of gets the descriptor for an object property. So you just add the object and the property name, and it'll give you a property descriptor object. And then you can actually change them with define property. So basically, you have the object and the property that you're trying to define, and then the property descriptor, which this is actually writing a property descriptor that has so this property is going to have a value of 42, and it's actually setting it writable to false. So with property descriptors, you can actually, in ES5 today, make things read-only, which is pretty nice. So I'm going to show some of the other things that property descriptors can do. So it actually obviously holds the value. So you can actually set the value of properties this way. You can do as writable or not. So it's like you can make things read-only. You can make configurable. So configurable means that the property descriptor for that object is mutable or not. So you can actually keep people from messing with your property descriptors. So if you want to kind of like finalize it, so this is actually used quite a bit for like internal properties that you don't really see that much, that if you were to actually mess with the property descriptor of it, it would break the language. So that's another option that you'll see on it. Enumerable. So if you do a for in over an object, you can actually get like a list of the properties of that object. This is actually will tell it if that shows up in that enumeration or not. So you can actually kind of hide things from your enumeration if they don't really make sense to enumerate over it. Again, that's usually for like internal properties, all that magic behind the scene and objects that make things work, like say prototype. If you do a for in, prototype is a property on objects. But if you do a for in, you're not going to see prototype in that list. So it's the enumerable here is false. And then we have get set. So believe it or not, getters and setters, accessors are a new feature in JavaScript, but you can actually do it in ES5 today, just with using property descriptors. Of course, it's kind of really ugly because you have to use the define property thing to be able to do that, but it is an option that you have that you can actually make use of property accessors in ES5. So what the decorator proposal has done is it kind of built off these property descriptors to make something called element descriptors. And this is actually what decorators take in and modify. And I'll show some examples of that later. But there's a few, explain some of these element descriptors in here. So they add some sort of things. So when you decorate a field, you'll have a field element descriptor. So these have a few properties. The kind, of course, is field. The key is usually the name of the field. So if you have a property that's called foo, key is going to be foo. And then it also will tell you the placement of that field. Static, own, or prototype. So static, of course, is static. It only is going to be visible to class. Prototype means like when you do a new object, it's going to do it. So methods are usually prototype. Own properties are properties that don't exist until that object is instantiated. So those are going to be pretty much your field properties are going to be own. So you might not see prototype actually in field element descriptors, but it's a possibility. Then you have your property descriptors are all those fields that I just mentioned in that slide before are going to be available here. And then when you return, like I said, so decorators take in element descriptor and they return an element descriptor as the response that's been modified. So there's a few other things that you add in here, like initialize and extras. So initialize basically is a function that gets passed when you initialize an object. When you initialize this object, this function will define that property with whatever the return value of that is. And this will make more sense when I get to the examples. And extras, pretty much all the element descriptors support extras, which is an array of more descriptors. So you can actually add on more descriptors to an object. Because if you take a field element descriptor, it's going to expect a field element descriptor back. But you can actually define methods and other things by passing more descriptors to the extras. Method is really close to the same sort of thing. The only thing is that instead of value in the descriptors, it's going to have a method property in order to get that, and that's just going to have that function. So you can take that function and wrap it into things. The class element descriptor is really simple. It just has the kind class and it has elements, which is just an array of all the other descriptors that's on that class, except for constructors. So the kind of thing with if you want to modify the constructor, you have to use a hook, which is the next time. So elements are going to contain all your properties and all your methods and all that kind of stuff, accessors in one giant array. And you can modify this, add things to the array, add more properties and stuff. Then we have hook descriptors, which is a brand new concept. So hooks are things that you add in your extras array in all of these descriptors. So hooks basically fire off at certain events in your thing. So start is, start, finish, and replace are the three kind of options you have when you define a hook. So start is going to take in either the class or the property when it's starting to get defined. And it returns undefined because this is sort of meant for when you want to do side effects when you start making classes. Finish is the sort of thing. So after the class is defined, it'll pass in the class and you don't return anything from it. And again, that's mostly for side effects. And you can have replace, which takes in a class and returns another class. So this will actually replace the class in your list of classes with this class, which I'll show you why that's handy in a bit. So let's get into some samples. So hopefully in this console here in about 5 seconds, there we go. I got a little thing here that tells me how long this method took to run. So you see here I have the time decorator, and I decorated a method here, and I have something that just takes like 5 seconds to do. So very simple kind of concept here. So hold on, I need to get into this. So this is what that descriptor looks like. So we get the element descriptor, which is going to be, since it's a method descriptor, we're going to get this is going to be a method type descriptor. So it's going to have a method, and we get the key because we need to know the name of the field. And then I'm going to replace that method with another method. So I have a replace method here, which I have a function. I just called it keep time. And does anybody know how console.time and console time end works? there's kind of a cool thing where if you give console.time like a unique field, and then later you can call console time end with that same key, and then it'll output to your console how long it took between those two calls. So you can use that to do some benchmarking stuff, which is exactly what we're doing here. So, so basically, I use that name of the method as a key in console.time. And then I return, then I actually apply that method. So basically, I run the method and get whatever it returned. Then I check to see if this is a promise, which those who do TypeScript might be appalled by this, but this is kind of how you do it in JavaScript, is you just see if it has a .then in its function. And then, so then I add a .then in that case and call time end. And if it's not a promise, I just call time end. And then I return whatever it returns. So that method is going to return the same thing that my original method would return. And then I return that whole element descriptor. So I do .element descriptor, so it copies all the existing properties, but then I replace the method with my replacement method. Okay, next sample. This is a React one. So I have a problem with my React script. Like I have this button that's supposed to be, every time I click it, it's supposed to show the numbers, how many times I clicked the button, and it's not seeming to working. So, so here is my React thing here. So I have basically a counter button here. It has this update count action, which does the set state, and then it increments the count of the internal state. And I have the render method here, which takes that update count method and then basically assigns it to the onClicked of the React element. So is there anybody here who does React that can kind of tell me what's wrong, why my script doesn't work? Alex. That is correct. So you basically have to bind out. So basically, since this method uses this dot set state, it doesn't know what this is when you pull it out of the object and then pass in that bare method, because it's basically an unbound method that's just like floating here and update count. So there's like a few ways you can do to fix this in React. You can do you can actually bind it in your JSX, or do an arrow method sort of thing here. This, I don't like this method because it makes your JSX look really kind of ugly. So I don't like doing this. It makes it harder to read. So another thing that people do is they'll change this to a property and make it into an arrow function. So this actually works too, but the problem is that this action method gets pulled out of my prototype and it becomes an own property, which means that if you inherit from this thing, then it's going to do some things that you don't expect, because that thing isn't going to be part of your prototype where you might expect it to be. It also causes problems with mocking. So if you wanted to mock this component, and you want to mock this method, usually the mocking frameworks take a look at your prototype to figure out what it can mock. So since this, like, we pulled it out of the prototype and it's now just an own field, so we don't like that method either. So the method that I usually like is to do reassign this to a variable this way. So this will work if I do it like this, but this is kind of boilerplatey, right? Because if you have like a whole bunch of actions in your thing, you're gonna like basically listing these out in your constructor, and it's just a lot of noise. So I got a decorator that can help out with this. So I add bound as my decorator, which I imported here. And let's see if that actually fixed my script. Oh, look, it works now. So I'm going to show you how this bound thing works. Thank you. So I have an element descriptor, which is going to be a property descriptor or a method descriptor here, since we're decorating an action method. So I'm going to pull out all these things here from it, the enumerable, configurable, and writable things, because I'm going to want to copy that later into my new thing. So I'm going to create an initialize function, which does the binding for me. So this is going to be when that class gets initialized, it's going to get a new this each time, right? So every time that the class gets initialized, this is going to be the right object, because this is going to be called each time that the class is invoked. Hope that makes sense. So I'm going to return the element descriptor. I'm going to add an extras. So extras, as I said, is a way you can actually define extra things into your script. So I'm going to make a field. I'm going to place it in own, give it the same name, and I'm going to copy all those other like enumerable, configurable, randable things from my other thing, and then I'm going to add this initialize method as an initializer. So the way that this works is it actually works the very same way that the constructor method I used, where it creates a local own property, and then it uses that sort of like initializer in the constructor that runs every time the object is run to basically bind a new thing. So this way, because I just copied the element descriptor as is, that method still lives in the prototype. And we have sort of like this field that kind of shadows it that actually has the bound function connected to it. Okay, next one. So I have a class here, foo, which has a constructor, this value, and it just does like a random number. And I kind of expected these to be the same. So I did some like debugging here to see if the objects were the same object, because I have A new foo and B new foo. Kind of wanted this to be sort of a singleton and get two values, and I can see here that they're not. So I'm going to add singleton here. And I'm going to run this again. And look, they're the same object now. Great. So let's see how I did the singleton thing. So this is, I'm using a hook this time. So again, I copied the descriptor as is, but I'm adding a hook here. I'm placing it in the static thing and I have a replace. So what this does is I'm taking a class and and then I return the, I'm basically extending that class with a new class, with a new constructor, with the singleton logic. So the thing that's kind of crazy about JavaScript is if you return the object from a constructor, then when you do new whatever, it actually gets the object. It's kind of, a lot of languages don't have that. So it makes this kind of pattern pretty easy in JavaScript. So basically all I did is I created a hook that actually runs when the class gets defined and replace it with an entirely different class that has the singleton logic in it. And because it does this new class thing args, then the original constructor gets called. So I still get that random number and stuff. So pretty handy object. I got one more to show you. I'm going to do some injection here. So DI injection. So I have this thing that's inject logger. And then by the time this thing runs, it's going to have a logger object in it. So I'm going to pull out my DOM logger object. So I have this other component that's decorated with this class here, which is decorated as a component, and I called it logger. So I'm doing name-based injection because that property is named logger. It's going to pull logger from my DI container. Then I have some methods here that other thing calls. So let's look at those real quick. So I have a really simple container, not really much magic here, but the thing that's cool about this one is it actually takes in an argument. So if you saw if I go back, sorry, to that class, you could see that it takes in an argument, right? So this is sort of tells it, I want to register this class under this name. So the way you do that is you take a function that takes in all the arguments you want from the thing, and then you actually return another function that basically is the same as your other decorators, kind of doing manual currying, basically. So we have a function that takes in a name, and that returns a function that takes in an element descriptor. So again, this copies the element descriptors over. Then we add another hook. So this one we're calling finished because we don't need to return a replacement class or anything. This is happening as a side effect, that it registers that name, which I pass in, with that class that gets passed in. So basically all this does is it registers that class to my container. And the inject is actually also really easy. So this is a field thing. So I want to get the name of the thing in it since we're doing name-based injection. And then in my initializer, so every time that the object gets initialized, I'm going to get the that particular class. So the container getting initialized to that class and passes it on. So so that basically does the injection for me and basically assigns that value that's in the container into my local property, and then I can use it. So just a quick conclusion. As I was saying, decorators, like I had to redo a lot of my slides because the specification was changing as I was writing it, but now it's kind of stabilized because I actually have the PR version of this. So decorators right now are a moving target, but like I said, on the 29th, hopefully it'll move stage 3 and then things will settle down quite a bit. So hopefully you guys can get a head start. But as far as using decorators, that syntax isn't going to change. So all these like libraries and frameworks that are already taking advantage of it, encourage people taking advantage of it. If you are wanting to write your own decorators, that's sort of up to you if you want to take that adventure or not, because it still might change until it gets to stage 3. So I hope you got something from this, and thank you very much.